Hey everyone. Today we're working on section 5.3, which is primarily about rules for integration. And the rules that we're focusing on will be for definite integrals. Okay, so we're going to start with the basic rules. So you're going to fill these in at the top of your worksheet. So the first one is what's called the order of integration, and that just means that you can switch the order of the values on the integral sign as long as you put a negative out front. So the integral from a to b of f of x would be the same as the negative integral from b to a. Then there's the rule about multiplication or division by a constant. So if you've got a number here in front of the f of x, you can take that number and pull it out front so that you're just integrating f of x. All right, the next two rules the next rule, I'm sorry, is sum or difference rule. So this plus sign could also be a minus sign. If you have two functions added together, let's say like sine of x plus x or something like that, you can separate them into two separate integrals. And then the last one is what's called the additivity rule. So this one is the integral from a to b of f of x plus the integral from b to c of f of x. So notice that the first integral ends on a b, and the second one begins with b, and there is the same function inside here and here. So then you can basically just combine these into one integral from a to c. Okay, so we're going to start off by using those rules first. So we've got some values at the top. So the integral from a to b of f of x is r, and the integral from a to b of g of x is s, and we're going to use those two pieces of information. So we have two functions added together, so their answer could be done separately or together, it doesn't matter, but this is r plus s. Okay, so this is the subtraction rule. So this is going to be r minus s. And then the next one down here is the constant multiple rule. So this is going to be 3 times the value of the integral of f of x, which is 3r. And then this one over here, it might be easier to understand if you think of it as the integral from a to b of 3 dx plus the integral from a to b of gx. So when we go to simplify this, we learned yesterday, there we go, that I can do a constant, take the integral of a constant by taking 3 times the top bound minus the lower bound, so 3 times b minus a. And we just saw at the top that this integral with the g of x is equal to s. So 3 times b minus a plus s. All right, and this is just the rules kind of put together. So you've got the addition rule and the constant rule. So this, I hope makes sense. It's going to be 2 times r plus 4 times s. The last one, same thing. 7 times r minus 2 times s. Nothing too tricky there. Okay, and then the next 4 questions are pretty much the same thing, just paying attention to the order of the integrals. Okay, so our rule here is that the integral from a to b is equal to r. This is actually a rule that we didn't write out, but I think we saw yesterday. If the top and the bottom bound are the same, then this integral is equal to 0. Okay, so notice this one, the values have been switched in order, so this is the same as the integral from a to b of f of x dx, but the opposite. So this would be equal to negative r. And then down here, we've got from a to b, but with the negative already there, you could take the negative, put it out front if it makes you happy. This is still, or again, equal to negative r. This one has the negative out front, but the order is opposite from the information we were given. So we could think of it as the integral from a to b of the negative f of x, which is just f of x dx, which again is equal to r. Okay, I'm hoping all of those are making sense. The next few are a little bit trickier, but still not terrible. All right, so what changes on the next slide is the fact that the order, the letters keeps changing. So you've got the integral from a to b of f of x dx equals r, and the integral from b to c of f of x dx equals s. So I could add these two together and have the integral from a to c of f of x dx would equal r plus s, okay? This is assuming that the A and the B and the C are all in this order from A to B to C, which actually is the answer to number one. Okay, so we literally I just did it over here in red. So I think I will just pick it up and drag it down here. Okay, so then number two, you'll notice that the order is not the same. So now we have the order from C to B to A. So if I'm going to write these integrals out, use my little sign over here, I'm going to write three of them out. So I know that the integral from C to B, and I'm just to save time, I'm not even going to rewrite the actual f of x dx each time. From C to B, that integral, plus the integral from B to A. So we go from C to B and then from B to A. Well, that is equal to the integral from C to A. Well, we don't know about from C to A, but we do know that the integral from A to C is equal to r plus s. So let's do this. Let's actually do each piece separately. Let me move this out of the way. So the integral from C to B is the same as the integral from, this would be the opposite. So this part right here, this first part would be equal to negative s. And then from B to A is the opposite of from A to B, so it would be negative r. And this is equal to the opposite of what I have when I add them together. So if I want to switch the order around, so I want it to be the integral from A to C, what I need to do, bring in a space here. Let's get a color. This would be equal to the opposite of what I have written here. So instead of it being negative s plus negative r, it becomes just s plus r, or r plus s if you prefer. This is the thing going in the opposite direction. All right, so I'm going to do the same thing with this problem here. I'm going to not worry about my integrals anymore. So I know that the integral from a to c plus the integral from c to b would be equal to the integral from a to b. So I'm just doing things in the order of the way the letters are written here. So a to c plus c to b would be equal to a to b. But I want from a to c, that's what the directions are asking me for. I want from a to c. So I know that would be equal to the integral from a to b minus the integral, this one here, from c to b. Okay, well, we know from a to b, that is equal to r. And this one, I could switch the order and make it from b to c, but switch the sign as well. So right now it's negative, so make it positive. And the integral from b to c is equal to s. Hope you're catching on to what's going on here. Okay, last one on this screen. I'm hoping that this is making sense to you. So it's going to be from b to c plus the integral from c to A would be equal to the integral from B to A. Oops. So hopefully you can see that I need to switch really pretty much everything here. This is from B to A. Okay. So I'm going to switch this order. Nope, I don't have to switch that one. Never mind. B to C is good. I have to switch from C to A. So B to C we know is equal to S, and then C to A needs to be switched, so it's negative A to C, and B to A needs to be switched, so it's negative A to B. And I know that negative A to B, can't even read my handwriting anymore. It's supposed to be a B. Negative A to B, from A to B is equal to R, so this will be equal to negative R. And I am going to leave my negative A to C on the left side and subtract this S. So it's equal to negative R minus S. But I'm going to divide by a negative so that the integral from A to C, that's right, you guessed it, is R plus S. Okay, the thing is, the reason this happens is because these values that you get in here would change from positive to negative or negative to positive depending on which direction you're going. So um, it would, they're all R plus S, but the values would be, obviously the actual answer would be different depending on which problem you're doing. All right, last but not least, just a few extra practice problems and then we're done with a short video for today. So I have these 3 rules, 2 of them for f of x and 1 of them for h of x. Then we're supposed to evaluate. Notice the caveat here, if possible. So there will be a few that don't work. So from 4 to 1 would be the same as the opposite of 1 to 4. So that's a 2. From negative 1 to 4, notice from negative 1 to 1 is 5. And from 1 to 4 is a negative 2. So it's 5 plus negative 2, which is a 3. And then from negative 1 to 1 is defined for both f and h, so that's good news. So for f, it's 2 times 5, and for h, it's 3 times 7. So we have 10 plus 21, which equals 31. All right, so then when I come down to these last 3 here, from 0 to 1, it's very tempting to think it is half of the integral from negative 1 to 1, but we don't know anything about symmetry of this function, and we don't know anything about, what's if the graph is even remotely the same. So you really just don't have enough information. So I'm going to write NEI for not enough information. All right, same thing applies here for E. So this is getting bigger. Instead of going from negative 1 to 1 like the problem suggests, it goes from negative 2 to 2, but that doesn't mean that, again, that we're just multiplying everything or doubling it or anything like that. So this one is also not enough information. And then this one here goes from negative 1 to 4, which would be fine if we were only talking about f, but we also have h in the problem, and h has no information about from 1 to 4, so this one is also not enough information. All right, I hope you enjoyed your short video for the night. Make sure you have written down any questions, and if you need to, go back and watch it again. We will go over questions around class.